Well, few people knows that nature has a second nature, so it actually has a dual nature. We all know dual nature from the famous example of light, which has a dual nature as well as nature itself. But how it comes, I tell you after the break. No, but I will tell you anyway if you stay. Uh, One end of the universe is definitely the far end of it. So whenever you try to see what's the furthest away you can watch, you just make a very expensive space telescope and point it towards an empty space, and finally you will see eventually galaxies that are flying away from us so quickly that the light never reaches us. So this is, as we all know, the outer edge of our discoverable universe. Outside, anything outside of it is completely unreachable for us in every sense possible in this world. So, but mm, we all already know, even if we don't really realize it, that when we're trying to magnify things smaller than an atom and trying to somehow detect them, because seeing is believing, but seeing is not possible in this case. So we can't see them, but they still try to, they, as the scientists, are vehemently trying to look for smaller and smaller stuff. So that's why uh, we probably all heard about atoms that are made from a core and whatever, a cloud of electrons and all kinds of things, and even it was put in layers, electron layers, you know. Okay, so that's all we could tell. But now we have an Excel table. Anybody can download the latest version, and it's like a weather forecast. It's showing us how the current status of our common belief about atoms and anything smaller than that is currently put together. Now, this is exactly the other end of the nature. That's the dual in it, because we once we have the outer end of our discoverable universe, and we do have its inner end at every single location. So an infinite number of locations actually, but wherever we magnify, we will eventually find something. Well, if we're trying to magnify a space where there are atoms, then obviously we will see the atoms real quick and immediately. Even watching too much, you can even move around those atoms and photograph certain characters printed in atoms, showing that we, the human beings, are almost invincible because we can already see the atoms, but we can't obviously. But anything smaller than that is even more horrible. Now, but what happens when we do magnify, but we magnify into a place where we can't really experience an atom? Do we find something if we magnify that empty spot? Have ever anyone tried to magnify a completely empty spot? Oh yes, Hubble have had, and it was Hubble's most famous picture when they were trying to photograph a place with nothing immediately visible. So that's it. That's what I wanted to tell you today.